In this video, we will discuss the continuity of some basic functions, the graph, the domains, the range, and the region of continuity and stuff like that. Let's start with polynomial functions, and let's start with the graph of y equals x squared. The rough sketch of the graph of y equals x squared. Y equals x squared is a parabola. So it is an even function. It is a parabola opening up. So the graph of the y equals x squared would look like this. So the domain of the graph, the domain of the function is negative infinity to positive infinity. The range of the function is going to be from 0 to positive infinity. Now, the function is like the continuity, if you have to describe in layman terms, if there is no break in the graph, no jump in the graph, and the function is continuous. In other words, if you can draw the graph without taking the pen off the paper, the function is continuous. Hence, y equals the function f of x equals x squared is continuous on the entire real line, is continuous on negative infinity to positive infinity. Now let's look at a graph of y equals x cubed. It's a cubic function. It really plays a big role in the future. In the future examples. So the domain of the function, the rough sketch of the graph would look like this. As you can see that the domain of the graph is going to be from negative infinity to positive infinity. The range of the graph is again negative infinity to positive infinity. At every point in the domain, the limit of the function at a point is equal to its function value, meaning there is no jump in the graph or there is no break in the graph. You can draw the graph without taking the pen off the paper. So the function f of x equals x squared is x cubed is continuous on the entire real line, is continuous on entire real line or on the interval negative infinity to positive infinity. Now let's take the graph of y equals 1 over x, and y equals 1 over x is a rational function. First of all, realize that. You want to make sure that the denominator is not 0 because division by 0 is undefined. Hence the domain of this function is going to be negative infinity to 0 union 0 to infinity, and the range of this function is also going to be negative infinity to 0 union 0 to infinity, and the rough sketch of the graph is going to look like this. The rough sketch of the graph would look like this. You can make a table of values and then graph it. So you will have the vertical asymptote is going to be the y-axis, the horizontal asymptote is going to be the x-axis. So you have a discontinuity at 0. However, the right hand limit at 0 is going to be positive infinity. The left hand limit at 0 is going to be negative infinity. So the limit does not exist at 0. Now you can also see that, but other than 0, the function, limit is equal to the function value. Other than 0, there is no break in the graph or no jump in the graph. Hence the function is continuous on the domain. So you will see that f of x equals 1 over x is continuous on the entire real line except 0, or in other words, negative infinity to 0 union 0 to positive infinity. Now let's take the graph of y equals 1 over x minus 1. This is really obtained by translating, by moving the graph to the right side by 1 unit. Moving the graph to the right side by 1 unit. Obviously you would have the vertical asymptote at x equals 1. So if you call this as x equals 1, so that's going to be, this is x-axis, this is y-axis. So now your graph of this function would look like, the rough sketch of the graph would look like that. If you make a table of values and graph it, that's how the graph is going to look like. Now the domain of this function is going to be negative infinity to 1 union 1 to positive infinity. The range of this function is going to be negative infinity to 0 union 0 to infinity. 0 to infinity. So the function, the left hand limit at 1 is going to be positive infinity. The right hand limit at 1 is going to be positive infinity. The left hand limit at 1 is going to be negative infinity. The right limit is not equal to the left limit, so the limit does not exist at 1. So the function f of x equals 1 over x minus 1 is continuous on its domain. So that means it's continuous on negative infinity to 1 union positive 1 to infinity. That's what we can tell about it. Or in other words, except at 1, it is discontinuous. But other than that, the function is continuous. There is no break or jump in the graph. So the function f of x equals 1 over x minus 1 is discontinuous. At x equals 1. So that's what is the continuity of the function 1 over x minus 1. Let's now consider the graph of y equals sine x. We all know that the graph of y equals sine x would look like that. The rough sketch of the graph would look like this. This is the graph of f of x equals sine x. The maximum value is positive 1, the minimum value is negative 1, and it's oscillating between positive 1 and negative 1. The domain of the graph is going to be from negative infinity to positive infinity. The range of the graph is going to be from negative 1 to positive 1. You can see that the limit of the function is equal to the function value at every point in the domain. So you can see that f of x equals sine x is continuous on the entire domain, in other words on negative infinity to positive infinity. Now you have let's consider the graph of y equals cosine x. In other words, the rough sketch of the graph of y equals cosine x. So this is going to be positive 1, that's going to be negative 1. So you have the graph of cosine x would look like that. So the domain of this graph is from negative infinity to positive infinity. The range of this graph is between negative 1 and positive 1. There is no break or jump in the graph. So f of x equals cosine x is continuous on the interval negative infinity to positive infinity. There is no break or jump in the graph. Again, one more time, you have let's look at closely about the function f of x equals tangent x. The tangent x has a vertical asymptote at pi over 2, and here it is negative pi over 2. So the graph would look like that. So the domain of this graph of the tangent is going to be from negative pi over 2 to positive pi over 2, because the vertical asymptotes are at pi over 2 to positive pi and positive pi over 2. The range of this graph is from negative infinity to positive infinity. Then you have the function f of x equals tangent of x is continuous. Is continuous on its domain. In other words, is continuous on the interval of negative pi over 2 to positive pi over 2. Let's look at the exponential functions. This is probably one of the most important functions in math. The graph of the exponential function would look like, that's the graph of exponential function. This is a rough sketch. The domain of this graph is going to be from negative infinity to positive infinity. The range of this graph is going to be from 0 to positive infinity. There is no vertical asymptote, okay, and the horizontal asymptote is really the x-axis. The y-intercept is really 0, 1. This is the y-intercept. 0, 1, and there is no x-intercept here. I mean, there is no break or jump in the graph, and you can draw the graph of the function without really taking the pen of the paper. So the function f of x equals e to the x is continuous on the domain. Is continuous on domain, in other words, on negative infinity to positive infinity. Now let's look at the another function, y equals e to the negative x. That's also one of the important functions. I mean, the rough sketch of the graph would look like this. I mean, the rough sketch of the graph would look like this. Again, the domain of this function is going to be negative infinity to positive infinity. The range of the graph is going to be from 0 to infinity, and there is no vertical asymptote. The horizontal asymptote is the x-axis. The y-intercept is 0, 1, of course, and the x-intercept is, there is no x-intercept because the graph does not touch the x-axis, or it does not cut the x-axis. There is no break or jump in the graph, or you can take the pen of the, you can draw the graph without taking the pen of the paper. The limit of the function at any point is equal to its function value. So f of x equals e to the negative x is continuous on the domain negative infinity to positive infinity. So let's look at maybe the natural log function. Okay, natural log function. So now the graph of the natural log function would look like, I mean, it's a, well, I hope you remember that, is rough sketch of the natural log of x function would look like this. The domain of natural log is going to be negative infinity, sorry, not negative, it's going to be from 0 to infinity. The range of this graph is going to be from negative infinity to positive infinity. There is no horizontal asymptote for this graph, and the vertical asymptote is really y-axis. There is no y-intercept, or the x-intercept of the graph is going to be when x is 0, y is 1. The x-intercept is when x is 1, y is 0. That's where this cuts the x-axis, so 1, 0. You can also see that y equals natural log of x is the inverse of y equals e to the x. Hence, if you put a mirror image like that, this is y equals natural log of x. But if you make a mirror image, this is the graph of y equals e to the x. I mean, if you put a mirror, you get the mirror image like that. My picture is not good, but actually y equals e to the x is the inverse of natural log and vice versa. So you can draw the graph without taking the pen of the paper, or there is no break or jump in the graph, or the function value is equal to its limit at every point in the domain. So we can conclude by saying y equals natural log x is continuous on the domain negative infinity, on the domain 0 to positive infinity. You can see that 0 does not belong to the domain of the natural log function. That's why we excluded 0 from the domain. So we, in this lecture, in this video, we saw the domain, range, x-intercept, y-intercept, horizontal asymptote, vertical asymptotes of some of the basic functions such as polynomials, exponential, natural log, trig. I mean, you can try try some other functions on your own and see how they work out. I mean, and check the continuity of the some other functions such as inverse trig or hyperbolics, and see how it will work out. If you have any questions, please let me know in the comments below. Okay, thank you. Bye bye.